Occupy Mars now seems just a good logo for SpaceX t-shirt, something we've been used to hear from Elon Musk and all those space geeks supporting SpaceX and its mission to colonize and explore the surface of the red planet. Well, staying and looking at the recent announcement from Elon Musk himself, well, it seems that they have recently decided that the moon is the real goal. But, well, there are precise orbital mechanics reasons. Well, look at this. Well, no, apart from jokes, it's actually precise orbital mechanics and also a good strategic and maybe business perspective. Now, let's talk a little about this from what we know from the recent public announcement of this company. Okay, you guessed, the first thing that comes to our mind when looking at the recent announcement of Elon Musk directly himself, well, it seems that the simple political and business pressure from the Congress of the United States and directly from the president, well, it probably is the main reason. Indeed, Donald Trump said that he wants a stable human presence on the moon by 2030, and this is the main goal that the Congress has set, basically to still giving money to SpaceX and, well, some other private companies revolving around this, well, not so small anymore ecosystem of space private business. Well, the point is that money is still the things that moves spaceships toward the moon and beyond. So this is probably the first motivation. Indeed, apart from the Artemis program, SpaceX is no more the only private company aiming for the moon. I'm not just talking about the US, I'm also talking about China and a more global perspective in this ecosystem. Well, private companies are no more so small that they just can count on, well, private funding, but also they have to face government approval and what the United States, for example, if you are SpaceX, are saying. So political moves are the key factor behind what you can do or cannot do in order to obtain funding from public institutions like the US Congress. So Mars seems not to be the main goal, something that Elon Musk himself and all those space geeks have said and try to spread like propaganda around all those space passionate, and not only them, but outside of this ecosystem in order to get funded for those space missions. So even though we are assisting to private phenomena, private products flying in space like Starlink and those products which are contributing to fund the space business, public institution like the Congress on your side is still fundamental for bigger goals like the surface of the moon. So this is the first and probably the most important factor in the whole equation of why Musk has recently said that Mars is deferred, is not cancelled as a goal, but it's no more the first primary one. The moon now is. But now let's look a little further and look at the physics, the orbital mechanics, and also something which may be defined as a more strategic development strategy for a company, not just a public agency. So they are not just doing research, they try to build and building fast. So let's first think about orbital mechanics, and there are some interesting aspects that I'm going to mention at the end of this point. So orbital mechanics is something which is crucial when you are targeting medium deep space missions. You may have heard about launch windows. That's something which takes into account the orbital period. So that's the time something which is revolving around something else in space takes in order to complete one complete revolution. So I'm talking about like 1 year for Earth around the Sun. So its orbital period is exactly 365 and some hours to complete one complete rotation. The moon has an orbital period around Earth around 28 days. Mars has a slightly longer than Earth orbital period. So if you combine the orbital period of Earth and Mars, well, you will obtain some time, usually in terms of very few weeks, and usually only around a couple or, well, 2 or 3 years to have at your disposal those few weeks, which are the exact amount of time and the exact when you have to launch something from Earth in order to optimize, so in terms of minimization, the time that you need to depart from Earth and to reach the red planet. This is how scientists usually calculate launch windows in order to simplify at the most this thing. So you get the orbital period, so the time Earth takes to revolve around the Sun, which is 1 year, and the orbital period of Mars. You combine those times and you obtain those time span when you can launch something from Earth towards Mars in order to minimize the time needed to travel from our planet to the red planet. That's how it works, basically. This is kind of simple orbital mechanics, basics orbital mechanics. So you need basically as a time to travel from Earth to Mars, usually something like around 6 months. Then you have your mission time, the time that you have to spend on the surface of the red planet and then get back on the moon. Well, you can think that you can just schedule a mission of 1 week on the surface of the red planet and then depart from there and get back home. Well, don't forget what we have just said in terms of launch windows. So the time that you spend on the surface of Mars may be enough in order to make you lose the next launch windows back from Mars to Earth. That's the point. So typical Mars mission profile in terms of timing is something like 2 to 3 years. So if you have humans, there are some, well, not just some, there are some few problems in terms of human resources, managing the problems that can rise during the travel, during the mission, and then going back home. So that's the main reason why we are still here and, well, haven't gone on Mars. That's the point, the main point. So orbital mechanics is still the bottleneck of the whole thing. Well, another thing that may be less intuitive, but if you're thinking about the development of a mission, is sort of a feedback loop that you may have in order to improve and to iterate the trials that you may compute and that you may have put in place in order to improve your mission profile and all those things that you may build and test them in space. There is something that we have already done in the past, like 50 years ago, that resemble what's happening now, and the reason why Musk has now been targeting to the moon instead of Mars. Well, think about the Gemini and the Mercury missions. Well, what they did was basically testing that what were the assumption of spaceflight were correct. Now we have far more knowledge on our side. We know much more about space systems, orbital mechanics, how the space physics works, and also some of those impacts on humans, for example, or on systems, on spacecrafts, on rockets. So we have much more knowledge on this side. But think about this. Well, when the Mercury and the Gemini astronauts flew for their very first times in space, still being in low Earth orbit, well, they didn't even have completed a full orbit around our planet. So we don't have to depart from zero now, but think about the docking missions that they attempted. So the rendezvous, the dockings, the maneuvering, the attitude of the spacecraft still around Earth before going to the moon. Well, that's something, if you think about like Apollo 13 mission that saved the lives of the astronauts. Well, that's because you have to learn and try to test and train your ability before in a familiar background and then in an unfamiliar one. So they firstly tested their orbital capabilities, they tested their docking capabilities, they tested the systems in order to validate them. And only once they were pretty sure, well, kind of low confidence, but they were pretty sure because at least one time they tested it, well, then they assume to be ready to depart from the moon. So think about you are going to test something for the very first time around the Martian orbit, like you're trying to land on the surface with a new spacecraft, well, Starship maybe, on the surface of the red planet with humans on board, and then I'm not saying that you're going to crash the whole thing, but maybe you are damaging it, or maybe you are finding out some new problems, you are finding out some problems in maneuverability, something that after a long time you find out is not as you thought. Well, that's a problem. So it's much better if with new variables like a new spacecraft, new systems, you first try in a familiar background, maybe something that they are already doing with unmanned tests of Starship around the Earth orbit. They still have to try to refuel between one Starship and the other around Earth. Then they have to find out how to transport humans around Earth, then around the moon, and then maybe they can validate this mission concept with very small changes in terms of variables by flying around Mars. That's how it should work. And that's basically, with the parallelism with what happened with Gemini and Mercury missions, well, probably that's the vision behind this decision. So first we try around Earth, something we've been doing for like 20 years with the International Space Station. Then now we can try to find out how it works around the moon and then aim for Mars. So if you want to test a new mission concept, new systems, new space things, you do firstly around the moon, because if you have a failure or minor problems, it's much faster to iterate, to do new tentatives around the moon, which is much closer than Mars. So let's say you're trying like even an unmanned mission with a rover like that. So you crash it, or well, you fail with minor problems. Think about intuitive machines, what they have done with their first two missions on the moon. Well, you have even minor problems on the surface. Well, that's much faster to throw another rover, another space system around the moon. So if you want to gather data, for example, in a matter of a couple of days, you can get all the data and the analysis in like 1 or 2 days back home on Earth. You have the full analysis, and in a matter of very few weeks, you are ready to launch a new spacecraft towards the moon. And so try well, again, so the feedback loop in these terms, so in terms of iteration, in terms of testing that you can perform, well, it's much closer, it's much tighter. So you can iterate much more times and improve at a much steeper rate than you would do on Mars. And so that's basically the main reason why SpaceX is now targeting the moon. Well, just to conclude and close the circle, back to the very first thing that everyone thought when this announcement got out, well, money is the main driver of the whole thing. Well, they still have to demonstrate that they have the technological capability to land people on another planet, another satellite. So instead of going on Mars, something that would require years from now, you have to demonstrate that you have that, like Starship you're building, all that technology, that know-how that you are building is still valid and it's applicable. So it's a real thing. So that you are capable of taking humans from the surface of Earth and land them on the moon. That's something they are required to demonstrate. So it's something the Congress may have been saying to SpaceX. So first you demonstrate me that you're capable of doing this, and then I'll give you the money to build all the other things. The very same that they did for the first Falcon rockets. At the very first steps they failed. All those rockets failed and exploded mid-air like that. So now it's the very first thing. It's similar, but again, new technology. So you have to iterate again and demonstrate the world that you're capable to do what you're saying. That's the reason. Next time we are talking about artificial intelligence in space, software and data centers. And again, maybe in another video, let me know if you want it. We'll talk about the next steps of Starship. So see you next time.